In 5.1, we talked about the average rate of change, where that is our change in the dependent variable divided by the change in the independent variable. And now we're going to do a little bit about our constant rate of change, where this is the special case where the average rate of change between two quantities is exactly the same for all points on our graph. And when that happens, this graph is a straight line. It's linear. And this constant rate of change is what we call the slope. And for a line, the average rate of change, so if we go ahead to calculate the average rate of change between any 2 points on our line, that is the same thing as the slope. They will be the same exact value if we have a line, a linear equation. So now our slope of a line, we're going to go through the definition or our equation for this with 2 points that we are going to call x1, y1 and x2, y2. So our slope m is equal to y2 minus y1 to give us our change in the y variables, divided by x2 minus x1. And now if you have 2 points, it doesn't matter which one you decide to give the subscripts of 1s and which ones you decide to give the subscripts of 2s. But what it does matter is that the ones that you decided to have the 2 on it, those are directly on top of each other. And the ones that you decide to give the subscript of 1s, those are directly on top of each other in this. You don't want to flip one of them, otherwise these minus signs are going to mess it up and you're going to get the negative version of the slope, but you want whatever. If it should be negative, you want the negative. If your slope should be positive, you want the positive, and you don't want to accidentally get the other sign of it. So now we're going to work through 2 examples of finding the slope of a line. So here I have been given the ordered pairs 5, 4 and negative 7, 12. And I want to find the slope between these 2 points. So with this one, I'm going to just give the first ordered pair the subscripts of 1, so x1, y1, and then my second ordered pair, I'm going to let be x2, y2. So now my slope m between these 2 points, well, y2 is 12, and then I need to subtract y1, which is 4. And then I need to divide that by my x2, which is negative 7, minus x1, which is 5. So this gives me 12 minus 4, that's 8, over negative 7 minus 5, that's negative 12. So this gives us negative 2 over 3 as our slope. The next one, we have the 2 points negative 3, 0 and 2, 3. So once again, I'm just going to let the first ordered pair be my x1, y1, and then the second one be x2, y2. So now for this sorted, or the slope between these 2 points, we have m is equal to 3 minus 0 over 2 minus a negative 3. So this gives us 3 over 2 minus the negative 3. The double negative means that we're going to add those two together. So that gives us 5. And then lastly, we're going to go over a little bit of some different cases of what lines look like with different types of slopes. So a horizontal line will always have a slope of 0. So that means that our variable x, if we're using x and y, no matter what you put in for x, the y value is always going to be the same. So the slope m is 0 and the mx portion just goes away. This gives us equations that look like y equal to b, because that's all we have left. The slope of a vertical line is undefined. Because if we think about a vertical line, if we graph a vertical line, the y value is the same, or sorry, the x value is the same for every single point on that vertical line, and that's not even a function, because you have one x value going to infinitely many different y values along that vertical line, so that's undefined, it's not even a function. The next one, a line with a positive slope. What this looks like, if it's positive slope, is it trends upwards as x increases. So if we go over to just a simple graph, what that means is as I move along left to right on my graph, the line is going upwards. So if I draw this with a green line here, it's going up. It looks to be going upwards as I move from left to right. So as my x's get bigger, it's going up. But now the next one, a line with a negative slope, this trends downwards as x increases. So if I graph this one over here on the right with a red line, as we move along from left to right of the graph, it's going downwards. And that is sort of what a negative slope looks like on a graph.